Hi, everybody. Today we're going to learn about reflection and writing transformations. Okay, so far we have learned about translations, dilations, rotations, and now we're going to learn the last type of transformation, which is a reflection. So let's talk about these function rules, right? So once again, the pre-image is these coordinates right here, the x, y, and the image, which is right here. Now we're going to explain what happened. And if you notice, they look a little different, don't they? They look a little different. And every one of these have their own rule. So I'm going to give you a little piece of advice. You got to remember these rules, okay? You just got to remember them, period. So you got to recall them. All right, in order to do the problems, you have to get to know the rules. All right. So first of all, let's go ahead and um, let me remind you again that pre-image is domain and input, and that image is going to be range and output. All right. So let's keep it moving. Here we go. The across the x-axis, we write this function rule like this: r lowercase r x-axis, and remember we start off with x, y. Okay. And it moves to x negative y. Now let's talk about that for a second. That means I am going to multiply y by -1. All right, so when you see that negative there, that means to change the sign or multiply by -1. That's what that means. So just the y coordinate gets multiplied by -1. All right, let's do the next one. Across the x-axis, the y-axis. So that's a lowercase r again, and then you write y-axis. Again, we start off with x, y, that's our pre-image. And then our image is going to be -x, y. Now, let's also talk about this part. That doesn't mean positive y. That means we don't do nothing to it. So we don't do nothing to the x, and we don't do anything to the y. So we don't do anything to the x, and we don't do anything to the y here. But for the x here, because it has a negative in front of it, we're going to multiply that x by -1, because that negative in front of it means to change the sign. Again, multiply by -1. Okay. Now let's look at reflection across the line y equals x. Line y equals x. So we would write lowercase r again, y equals x like so. All right, x, y. And if you notice, OMG squared, those coordinates switched. So when we do that, switch the coordinates. Switch the coordinates. Switch x and y. That's what happens with that rule. We switch x and y when you reflect over y equals x. That makes sense though, because you think about it. Y equals x literally means that y is equal to x. So that means you're going to switch them. Okay. All right. Let's keep it moving. So y is equal to -x. That literally means that y is equal to the opposite of x. Think about that. So, and here we see that well, let's go ahead, lowercase r again. Lowercase r, y equals -x. Here goes our pre-image. And then our image, look at that. So they switch just like the first one did, just like y equals x did. But in this case, they're both negative. Well, not both negative. Let's not say it like that because that would be wrong, right? We switch x and y, and then we multiply both of them by -1 and multiply by -1. And that's both of them. We multiply both of them by -1. So now let's get down to the last final one. And I guess it's not too different. This is actually a reflection over the origin. Now, reflection over the origin is the same as a rotation of 180 degrees. The same. So that means it's going to follow the same rule. And if you notice here, again, lowercase r, and you can write origin, or you can write 0, 0 like that, right? So you can write origin or 0, 0 either way, like that. All right, and then your preimage and your image. So all we do is multiply the x and the y by -1. Multiply x and y by -1 to get that. And that's how you do a reflection. That's how you understand the rule anyway, right? So remember, a reflection of the origin is the same as rotating 180 degrees. So let's go ahead and get to an example. I actually have a couple of examples for this one because um, these are the general rules for reflection, but then we have another one that we got to look at too. So the first example, it says, what is the rule of the reflection? So like we did in previous videos, we can just look at the coordinates because we know what's supposed to happen, right? So I'm looking at M, and I'm going to look at M prime. So M is -5, 4, and M prime is 5, 4. So if you notice, my x coordinate, my y coordinates did not change. Y coordinates did not change, but my x coordinates did, right? The image is the opposite of the pre-image. So which rule up here only says to change the sign of the x coordinate? So looking at the first one, we don't do anything to the x coordinate. Looking at the second one, that's the only thing we do. We just change the x coordinate. So it looks like this is going to be a reflection over the y-axis. Let's keep going, though. Let's check the other ones. This is a switch. This is a switch. And this changes the sign of both. So this is definitely a reflection over the y-axis. So this is going to be a reflection over the y-axis. And the rule for that is -x, y. So now look at my answer choices. -x, y is the first answer choice. Reflection over the y-axis, -x, y. It's not this one because it changed the coordinate, the y coordinate. That's why it's not that one. It's not a reflection over the x-axis, so that's why we didn't choose that one. Those last two. All right. So moving on to the next example. Well, actually, let's pause right here so you can write some things down. All right, so here in this example, we're going to look at how to do the other rules, right? So let's do a reflection over the x-axis with this quadrilateral. So here I have the coordinates. I already went and found them, wrote them down so that I can just apply the rule. Now, the rule for the x-axis, reflecting over the x-axis, is going to be, we don't change the x, and we multiply the y coordinates by -1. So we don't change the x, and we multiply the y coordinates by -1. So here the first coordinate is we don't change the x, okay? And we're gonna multiply the y coordinate by -1, but because the y coordinate is 0, 0 times -1 is just 0, okay? So we don't change the x, leave that alone, and let's just go ahead and do the other ones where we don't change them. And then we multiply the y coordinates by -1. So this will be -4, -5, and -2. Now let's take a look at a picture of it so that you can see that it ends up being a reflection over the x-axis. So here's the x-axis here, and here's the y-axis here. And as you can see, it has been reflected over the x-axis. Now I want to point out one more thing to you. Do you notice that this point right here is actually on the line of reflection? This is the line of reflection. This is on the line of reflection. So whenever you have a point on the line of reflection, that point is actually going to remain in the same place when you do a reflection. So when you have a point on the line of reflection, that point actually ends up staying right there on the line of reflection when you do the transformation. So that's why -2, -2, 0 is the same. It didn't change. All right, let's do another one. So let's take a look at reflection over the y-axis. All right, so a reflection over the y-axis follows the following rule where we just switch the x and y coordinates. Okay, so let's just switch the x and y coordinates. So that's going to be 0, -2, 4, -4, 5, -2, and 2, -1. That was quick and easy. All we had to do was switch the x and y coordinates. All right, so let's take a graph of that and look at what that looks like. All right, so that's the picture of what that looks like. Now, let me show you where the line y equals x is located, all right? So the line y equals x, remember I said that means y literally equals x. So that's 1, 1, that's 2, 2. So that means the x and y coordinates are the same. 3, 3, 4, 4, and 5, 5. So this is that line. This is the line of reflection here. Okay, and as you can see, all of the points are the same distance away from this line. Do you notice that? Right, so let's do this real quick. So look, that's one away, that's one away. It's literally a mirror image, right? That's about 1.5 away from that line. This is about 1.5 away from that line. Oh, again, these are just approximates. But you can see that the lines are just, excuse me, the figure is the same distance away from the line of reflection. And this is our line of reflection, which is y equals x. And we can see how it looks. It was reflected. It's literally a mirror image. All right, so let's pause right here so you can write some things down. All right, so for this next example, we're going to do a reflection over the y-axis. Now, we already did that one up there, but an example of that up on top. But we're going to do it again just to make sure you got it. So the rule for the y-axis is, again, we're going to change the x coordinates. We're going to multiply that by -1, but we're not going to do anything to the y coordinates. So the y coordinates stay the same. Y coordinates stay the same. And then we multiply the x coordinates by -1. So -2 times -1 is +2. That's -4 times -1 is +4. -2 times -1 is +2. And -1 times -1 is +1. And there goes our points. So let's go ahead and graph this so you can see what it looks like. So as you can see, just like the last time, this is our line of reflection right here. And you can see that the points are still the same distance away from the line of reflection. All right, and so that's how it looks when you reflect over the y-axis. Okay, all right, let's look at y equals -x now. So with y equals -x, the rule is not only are you going to switch the x and y, you're actually going to multiply them both by -1. All right, so here's what I do. I usually do this in 2 steps. I go ahead and switch them first, okay? And then I go ahead and change the signs because I don't want to get confused, right? So now I'm going to change the signs of the x. So 0 stays the same, -4, -5, -2. And I'm going to change the signs of the y's. So +2, +4, +2, and +1. And there you go. We have our new set of coordinates. So let's take a look at the graph to see what that looks like. All right, so there we go. We just plotted those points. So I want to show you something. Do you see how they overlap in each other? But here's the deal. The line y equals -x is right here. Okay, going right through, because y is equal to -x, meaning that they're the same number, just opposite signs. So there goes the line of reflection. And as you can see, the points are still the same distance away, right? So this is still the same distance away as that, right? And even though it overlaps, this blue part over here is still the same distance away from this line as the red is from that line, the line of reflection. So this is the line y equals negative x. Let me get that. So the line y equals negative x. All right. So last but definitely not least, let's do a reflection over the origin, which is the same as 180 degrees. Let's do that real quick so that you will see how that looks. A 180-degree rotation. All right, so that's the same as that. The rule for this is negative x, negative y. So we're simply going to change the signs of the x and the y coordinates. So that's going to be a positive 2, 0 stays the same, a positive 4, negative 4, a positive 2, a negative 5, a positive 1, a negative 2. And now we're going to plot the points. So remember, when you came up with these points, you were multiplying by negative 1. So negative 2 times negative 1 gives me a positive 2. 0 times negative 1 gives me 0. Negative 4 times negative 1 gives me a positive 4, and so on and so forth. All right, so let's go ahead and plot these points. All right, so now when you look at this, you can really see that it is a rotation, right? So this literally was flipped right here, and then maybe flipped down across the x-axis, and then flipped over across the y-axis to get here. So that's 180 degrees rotation, essentially. So you see that it was actually rotated the way the picture is flipped. All right, let's do one more example, and then we're all done with reflection. Wow, I said one more example, but we actually have two. No worries. This is going to be quick. So with this one, you have to figure out what is the equation for the line of reflection used in the reflection transformation below. So here I see a picture is reflected. The pre-image is blue and the image is red. My line of reflection is going to always be in the middle, as you saw in the images that we did up there on the last example. So let's go to the middle right here. And this is going to be my line of reflection. Let's just draw the line. Okay. This is going to be my line of reflection. We got to figure out what that number is. So it's going through the number 6. It's a horizontal line. So a horizontal line through the number 6 means the equation is y equals 6. So my equation for my line of reflection is y equals 6, because it's the horizontal line through the number 6. So that's y equals 6. That's how you come up with that equation. All right, let's look at the last example. Hey, so this is the last one. We have a vertical line at x equals -1. Okay, so let's look at that real quick. So vertical line, and that means it's going through -1. So when you look down here, it's going through -1 on the x-axis. Right, and so let's go ahead and write this through 6 on the y-axis. Okay, so now this one says perform the reflection over x equals -1. So remember, in the previous examples, we talked about how a reflection is literally a mirror image. It is the same distance over the line of reflection. So I'm going to start with this point right here. This point is actually 3 away from this line. It's 3 away. 1, 2, 3. So that means I need to go 3 over on this other side of the line. So that's 1, that's 2, that's 3. So my new point is right there. Now I'm going to do that for all of the points. So I'm going to also do that for this point, and then I'm going to do that for this point. All right, so let's go ahead and do this for this point. So this point is 1, 2, 3, 4, 5, 6, 7 away. So I got to go 1, 2, 3, 4, 5, 6, 7. And that's the location of my new point. And finally, the last one, I want to find out how far this is from the line of reflection. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And so I need to go 9 over 1, 2, 3, 4, 5, 6, 7. I already knew that was 7. So 8, 9 right here. And so now I connect the dots to create my triangle. So here is my triangle reflected across the line x equals 1. X equals -1. There you go. Now, here's one more thing that I want to do here for this problem. I want to teach you how to write the function rule for this, okay? If you notice this distance, right, it was 3 on this side and 3 on this side. So that means it's a total of 6, right, as far as the distance go. I want you to know that the distance is always twice whatever the for the reflection. So let's talk about how to write a function rule though for this. So x equals -1. We know that this is a reflection, right? We know that it's a reflection, that we're reflecting over the line x equals -1. That's what we know. So let's go ahead and make that note. It's a reflection. Now, in mathematically, a reflection literally means we're multiplying by -1. That's what it means, which has nothing to do with the fact that this is a -1 right here. But we're multiplying by -1. Now, this number right here tells us what line are we going, what number we're moving from, what's the distance, right? We're moving from here, right? So we're at -1. That means that it's going to be at least 2 away, right? So think of it as twice. So if the number was -4, then it would be 8 away, right? If it was -6, then it would be 12 away. If it was -5, it would be 10 away. So double that distance, because that's what's happening when we do it on the picture. So here's how you would do the rule for this. If you notice in this picture, the y coordinates did not change. So the y coordinates remained the same. What did change though was the x coordinates. So the x coordinates were reflected. And then remember the number was -1. So that means the distance was moved to the left 2 units. All right, to the left 2 units. Now we can check the points to make sure that works, right? So, and your teacher will go over more of that with you in class. So I just wanted to leave you with that to get you started with it. So this is actually a question that actually shows up on the test. All right, so this is a test question. Actually, let me just do one of the points. So we have 2, 5 is the original point, 2, 5. 2, 5 is the original point. So let's apply it so that we can see what the new point is. So 5, because the y coordinates didn't change. But now we're going to do the opposite of 2 minus 2. The opposite of 2 minus 2. The opposite of 2 minus 2 is -4, 5. So is that my new point? Is that this point right here? And we check -4, 5. Yes. So that is our point. That's how you write the function rule for this. Okay. Let's do one more just to make sure we got it. So if my function rule was x equals -2, given the line of reflection was x equals -2, then my function rule would be the y coordinates would stay the same. It's a reflection, so I would do negative. But the distance, right, instead of multiply that by 2, so it's going to be 4 that we moved. All right, let's do a positive number now. Let's say we reflected over x equals 4. Let's say we reflected over x equals 4. Then, okay, again, the y coordinate wouldn't change, but the distance instead would be 8. So again, it was still reflected, But instead of moving to the left, it actually moved to the right. So it would be a positive 8 because it's twice 4. Now let's do the y coordinate, all right? Let's do the y coordinate. Let's say, let's do the problem y equals 6, which we had up at the top. So that means my x coordinate did not change, okay? But my y coordinate did, all right? It does change. So again, it's reflected, all right? But that distance, right? That's a positive 6. So that means that's going to be a positive 12 because you got to go twice. Let's do it one more time. This time, let's do a negative number. Let's do negative 3. So once again, my x coordinate doesn't change. Okay, it is reflected, but twice negative 3 is negative 6. So that would be the function rule for that. And that's how you write function rules for when the line is just x equals a number or y equals a number. That's it.